Live stream for covering some homework answers on graphing the reciprocal trig functions. That is to be the the cosecant, the secant, and the cotangent. My name is Brian McLogan, and I am going to work through these examples to help you out. If you are one of my students, or obviously if you are taking a class where you are covering some trig, either in Algebra 2, college algebra, or looking into calculus and just kind of refreshing. And I kind of take the calculus approach, and what I mean by that is not really a calculus problem for these, but when I'm talking about like understanding the graphing, I want students to be able to understand the basic characteristics of the trigonometric functions as far as their graph, and as well as just getting a general idea of the sketch of the graph. So therefore we can identify the period, the amplitude, and the intercepts and asymptotes to better understand what is going on with the function. And those are some skills that, when I was teaching calculus that, we wanted students to know, not, how good are they at like plotting points and all that kind of stuff. So that's just kind of the approach, what I mean when I'm talking about the calculus kind of based. So anyways, we're just going to be working on all the reciprocal functions here. You can see that I have 2 of each. So even though they are very much related, they do have some differences. And then we are going to look into some multiple choice questions just to kind of get prepared for our upcoming quiz that is going to be coming up on this, that I'll also do a live stream for you guys that will cover the answers, kind of from there. So you guys can already have started coming in. VSAT, Rockers Infinite, good to see you guys. Ben, I'm happy to have you guys join me on here. If you guys have any questions or anything else coming up, I will happy to answer your questions about math, about preparing for upcoming exams, because I know many of you, at least that are following, the calendar year schedule, are going to have upcoming exams here in these next couple of weeks. So a couple announcements here letting you guys know I am looking into doing some live streams, some extra live streams where I'm not actually covering any of my content, but really just here to answer questions that you guys have. So if you guys have some reviews or you're working on some problems, preparing for your exams, I'm going to start looking into going live probably back in on the weekend. We'll see how the little kiddos behave for that, but we'll look into maybe doing some live streams over the weekend where I can kind of just answer some questions and just kind of do a little freestyle. So hopefully that will help you guys out. And yes, not to fail, Ben, for Algebra 2. So that's why I'm here, to help you guys out, answer your questions. So I'm going to get now into the live stream and the work, and I'm just going to dig my head deep, explain the process. And then obviously if you guys want to answer some questions, feel free to add them into the chat. And then once I take a break from the free response into the multiple choice, we'll go ahead and take a little break. So, all right, for the secant, we need to find the period, the phase shift, vertical translations, domain, range, and asymptotes where applicable. And obviously these all have asymptotes, but they don't all have phase shifts. They don't all have vertical translations. So if they don't have something like that, then I'm just going to leave that out. All right, and I did forget to add in reflections, so we are going to want to include that as well. All right. So in this case, if I'm just identifying these, if you guys remember, like my A is going to be 1, my B is going to be 1, and A is going to affect our range. Remember, it's not going to be our amplitude. That was only for sine and cosine, but our A does impact our range, and that's why I'm a lot of times going to look at the reciprocal function to help us not only sketch the graph of our function, but to understand our characteristics. So in this one, is pretty simple. You can see that the only thing really going on here is I'm shifting the graph pi halves to the left. So let's just do the period here, because since B is 1, remember the period for secant and cosecant is 2 pi divided by B. So in this case, it's just going to be 2 pi over 1, which is 2 pi. And then we also have a phase shift, which is going to be pi half units to the left. All right. So that's basically all of our transformations that are going on. Let's go and take a look at what this graph is going to look like. And actually, one thing I should mention is we know that the only thing that's happened to this graph is being shifted pi halves to the left, right? So the only thing really that's going to change is the domain, as the asymptotes are now going to be affected. As far as the range of our initial period, which we talked about in class and like on the notes, the range from the initial period has not been impacted at all. The only thing that's happening is the graph is shifted to the left. So I am just going to write the range from my initial period. I'm not going to go on and explain that. And so we're just going to go with the initial period range, which is, in our notes that we talked about, from negative infinity to negative 1, union from 1 to infinity. And again, I guess I'll just clarify for maybe some of you that don't understand that. This is the reciprocal of cosine. The range of cosine is from negative 1 to 1. And so what we looked at is this graph is basically the reciprocal of that, like it's going in the opposite directions. So basically it covers all real numbers except from negative 1 to 1, which you can see how this range represents that. And actually, let's just kind of like do a quick little sketch here. Now, typically the initial period started at 0, right, and ends at 2 pi. But, the nice thing about doing a rough sketch of the graph is I can start wherever I want to. So I'm just going to say, I'm going to start at negative pi halves. Okay? And again, we're doing the reciprocal of cosine. So I'm going to go up to 1 and down to negative 1. And then the graph would look something like this. So therefore, by graphing my secant graph, I know I'm going to have a vertical asymptote here, vertical asymptote here, and then I'm just going to kind of follow this way. So that by sketching the graph is actually usually what I like to do here when looking at more advanced problems for domain and range. But you can see here how the range is from negative infinity to negative 1, and then from 1 to infinity. I'm going to kind of change my tick mark here. Let's make that negative 1. Just cross that out. Okay, but now let's go and figure out where are these asymptotes occurring, right? Because our graph got changed. So we got to understand secant. Where are the asymptotes for secant? And on our initial period in our graph, we found the asymptotes to occur at x equals pi halves plus pi n. So now, if you can see, if we have a transformation, instead of the asymptotes occurring at pi halves, if I shift that asymptote to the left, I'm going to get to 0. So it's really 0 plus pi n, which we can just write as pi n. Algebraically, what we can do is just take whatever's inside the parentheses and set that equal to your original asymptote equation. And then when I subtract pi n, pi over 2, I get x is equal to 0 plus pi n, which is pi n. Okay, so I talked about the range. The domain is always going to be all real numbers except for where these asymptotes occur. So therefore, I can write all real numbers such that, all real numbers such that x cannot equal the asymptotes pi n. All right. Now, I'm actually going to work to secant just because it has the same qualities. So I think it'll just be easier for teaching purposes to kind of make that continuity. And then I'll do the cosecants. For this next one here, you can see that I now have a negative outside of the function. So that is going to be a reflection about the y-axis. And then also we have a shift up 1. Now, the important thing about this graph, or the important thing we see here, is now I have nothing that's going on inside of my function. So my graph is not shifting anywhere. And what we talked about was reflections did not affect the asymptotes as well. So really the only thing we need to be concerned about in this one is what is going to be the change in our range, because the domain is going to be the same as our initial period because the asymptotes are not being changed. The only thing that's happening is the graph is being stretched from negative 3 to 3, being reflected about the y-axis, and then being shifted up 1. So the asymptotes, when we do all these operations vertically, it's not going to affect them. The period has a b is 1, so that's just going to be 2 pi. We do not have a phase shift. We do have a vertical translation, which is up 1. And we have a reflection about the x-axis. I'll just write that. Reflect x-axis. All right, so let's just go and do like a rough sketch here. So again, what happens here, see here's 1 because a was equal to 1, right? But now when I have 3, that's going to change my amplitude from 3 to negative 3, and then I'm going to shift that up 1. So now my new range is going to be from, from negative 2 to 4, right? So it originally got stretched from negative 3 to 3 and then got shifted up 1. And then also the graph is being reflected. So instead of it starting up top, going down, if I was to reflect this graph, just do a quick little rough sketch that I'll delete, you know, the graph would look like that, right? So that's our shape of our graph here is going to look something like that. And then again, my period does not change, so therefore that's just going to remain at 2 pi. So my graph will look something like that. All right. Now our problem is, again, we don't need to figure out where these asymptotes occur because we know where these asymptotes occur because the graph never changed horizontally. So we'll come to that later, I guess. Let's just go ahead and sketch our graph. That's going to be at pi halves, and that was at 3 pi halves. But either way, let's just sketch the graph here. And you don't really need to sketch the graph because hopefully just by looking at the cosine graph, you can see that the range is going to be from negative infinity all the way up to negative 2, and then union 4 to infinity. All right, and then the domain, again, or let's look at the asymptotes first. The asymptotes are unchanged because there's no change there, so that's just going to be x equals pi halves plus pi n. So therefore the domain is all real numbers such that x cannot equal pi halves plus pi n. Bam. All right. Let's go ahead and move on to the cosecant. Now the cosecant is very similar. There are a little bit of differences. Obviously it's the reciprocal of the sine function, and the graph of sine is very similar to cosine, but it's different. The equation for the asymptotes is x is equal to pi n. So again, this is stuff that we kind of talked about in our notes. And really, yeah, that's kind of like about it. They have the same range, and really the same process is the same. In this case, you can see we have a 2 for our b. So when I do my period, I do pi 2 pi over 2, which ends up giving me pi. So we can see that the graph is being compressed by a factor of 2. I'm shifting the graph down 1, so I'm just going to say vertical shift down 1. Now, to kind of look at the sine graph, just remember, let's kind of look at there. So the sine graph, just like cosine, from 1 to negative 1, completes it in 2 pi. So that is across that pi. So that graph looks something like this. That's the parent graph there. So you got to think like, what is happening with this graph now? Now, this graph is being compressed to finish a whole cycle, not between 2 pi, but now between pi. So it's going to look something like this now. Right? So you can see that this graph is being stretched and compressed. And again, what that's going to do is that's going to move our asymptotes. Now the graph is also being shifted down 1. So basically, let's see if I can move this. Yep. So now you can basically take that graph, and my graph is very poorly written, so it doesn't work that way. But you can see now that's where the graph is going to be totally shifted down 1. So what I'm going to do is just, oh, I guess I'll keep it right there. That's fine. Well, let's delete that though. So by looking at, let's do it in just like a different color, maybe purple. So now the sine graph is going to go, well, it completes that in pi actually. So it's going to go here, and then it's going to go down to negative 2 now, because it still has the same amplitude, up 1, down 1. And that's complete there. So it's just important for us to see like what this graph looks like. Now, when we're looking into actually graphing the sine, same kind of thing. Like we're going to have our asymptote here at where the original intercept would have been, because the original intercept was at pi, right? The asymptote is at pi n. But since the graph got compressed, we can make a distinction or a good guess that it's going to be at pi halves, which is correct. But we, you know, as I mentioned, we just got to be careful sometimes, because sometimes the math will trick us, especially when we have like asymptotes there. So by looking at my graph here, I kind of have too much work going on, but you can see this secant graph here. We can see the range. To identify the range is going to be from, not included, negative infinity to negative 2. And then union, we can go from 0 to infinity. And then when I'm looking at the domain, I can probably make a good guess that it's going to be at pi halves plus pi n. And the reason why I'm making that distinction is I can see, at pi halves plus pi halves n. Because what I'm seeing is not only is the period getting shrunk by 2, but the distance between asymptote, which originally was pi, is being reduced by 2. But I don't need to make any of those guesses. All I simply need to do is set what's inside of my function equal to my original asymptote equation for secant. And when I divide by 2, I get x is equal to pi halves n. And you can see that is going to represent pi halves n, pi halves, pi, 3 pi halves, 2 pi, and that works. So my domain is going to be all real numbers such that x cannot equal pi halves n. All right. All right. One more for the cosecant, and then we'll get to the cotangents. And then I'll just go ahead and take a little break for those of you that are joining in on the live stream, and we'll just take a nice little break. All right, so y equals 1/2 cosecant of 2x minus 2 pi. So again, our main thing is I want to make sure that whenever I have multiple operations inside of my function, I want to make sure that's written in the form b times x minus c. So to do that, I'm going to factor out a2. And by factoring out 2, I'm left with an x minus pi. Okay, so what I can see here is now I can see I have a lot going on. I have an a, b, and a c, right? Again, no d. So what I want to do in this case here is, we don't need to worry about the a right now. We know that's going to be compressing the graph. I can figure out the period. That's easy. So that's going to be 2 pi divided by 2, which is equal to pi. My phase shift, I can see that this is just going to be going pi to the right. So I'd say pi to the right. There's no vertical shift, so we're good there. And again, let's just kind of get an idea of what this graph is going to look like. So I'm going to kind of use the sine graph again. But now, instead of going up 1 and negative 1, I can see that the graph got horizontally compressed by 1/2. So the sine graph is only going up as high as 1/2 and as low as negative 1/2. The graph also got shifted pi units to the right. So if the graph originally starts at 0, but is now being shifted to the right, I'm just going to say that this new unit is pi. And now the period is pi, right? So that means it's going to complete a circle in pi. So, I mean, it's nice to sometimes like graph the function with transformations based on the parent function so you can see these transformations, but it also can be kind of confusing. So what I'm just going to do is say, well, from pi, if I add pi to it, that's just going to take me to 2 pi. It's a much shorter period, though. It's like basically going from pi to 2 pi on this graph, right? So it's smaller. I'm just kind of expanding it for purposes here. And then we'll just kind of graph the sine graph. Looks like that. But at least from there, I can figure out what my graph would look like. And again, you don't really need to sketch the graph to identify the range. Hopefully by this stage, you're kind of like, okay, I get it. The range is going to be negative infinity to the minimum of the sine graph, which is negative 1/2. And then union the maximum of the sine graph to infinity. And the domain, you can see here, we're just going to take whatever's inside of our function and basically kind of set that equal to 0. So I'm going to use this form here. So actually, you know what? Yeah, I will. No, let's do this one. So if I just take my asymptote and I just say 2x minus 2 pi and set that equal to pi n. So yeah, okay. If I add 2 pi to both sides, I'm going to get 2x is equal to 2 pi plus pi n. Now again, I can't add this extra, I can't add these together because this has a variable n and this does not. But now I can divide by 2 here, and I would get x is equal to pi plus pi halves n. Okay, and what you can kind of notice here is if you were to keep on, adding or subtracting these, we'll just leave that, add that be. But you might want to look at, different variations of this, and different variations of this are going to keep on giving you all the asymptotes that are going to be occurring at pi halves. So you can see that these asymptotes occur at pi halves plus pi. So that actually would be fine. I'll work with that because if that's 1, then that's at pi halves. Pi plus pi halves. That'd be 1.5. Okay, that worked. So the domain here is going to be all real numbers such that x cannot equal pi plus pi halves n. All right, so now let's get into the cotangent here real quick. Cotangent doesn't look anything like the cosecant or secant. It looks a lot like the cotangent graph, right? And again, we discussed all of these by using the points on the unit circle, especially the x and y coordinates or the intercepts on the unit circle. The same process applies. Again, there's not going to be an amplitude here. That 3 is just vertically stretching the graph. And really, the main thing is understanding what the initial period, looks like for this. And so we'll kind of do that. And then also understanding the asymptotes. The asymptotes for the cotangent function, remember, is x is equal to pi n. All right, so the period also, this is very important. The period is just like tangent. It's pi divided by b. And you can see here my b is 1. So the period in this case is just going to be pi. I do have a phase shift, though. I am shifting the graph pi half units to the right. All right, so let's just go and sketch the initial period here, just so you guys can see it. So initial period is actually, if this was 0, then this would be at pi halves. Actually, you know what? Let's move that over. Stupid. No. Stop. Okay. Let's put it over here. And then, let's see, we're going to have an asymptote here at pi. And the graph looks something like this. Okay? So, if I was going to draw this graph with a vertical stretch of 3, the graph is going to be skinnier, right? But then also, instead of the graph having an asymptote, which I didn't show, having an asymptote at 0 and pi, and an intercept at pi halves, it's now everything's going to be shifted over to the right 1/2. So now this graph is going to look like this. So it's going to have an asymptote at pi halves. So this point has been moved to pi halves. The new x-intercept has been at pi. And then we have pi halves plus pi, which is going to be at 3 pi halves. So if you needed to kind of just do a rough sketch here, and then I'm going to do my best skinny graph. There you go. Okay, again, not being perfect, but just to kind of like understand what's going on. The nice thing about at least the cotangent graph is the range is really easy. You can see that the graph continues indefinitely in the positive negative direction, so it's all real numbers. And again, like, I'm going to kind of make this simple. The asymptotes occur every pi n. So they started at 0, and then you just add pi. Well, now I'm starting at pi halves, but the distance didn't change. The only thing that happened with this graph, it got vertically stretched, and then that shifted over. So every asymptote is still going to occur every pi n. So as far as my asymptotes go, that's just going to be x equals pi halves, which is my new starting point, plus pi n. And if you want to do the algebraic process what I did, set this equal to pi n, you would see it's going to be pi halves plus pi n. So the domain here is going to be all real numbers such that x cannot equal pi halves plus pi n. All right, last one of the free response. And this one, again, doesn't look that user-friendly as far as identifying the b. So what we'll want to do here first is take out the negative 1/2 and put that out in front. Therefore, we can see this is our b. Again, b is going to change our period, but it's not going to be a negative period. In this case, that's really the only thing that's happening. So my period is going to be pi divided by 1/2 Multiply by the reciprocal, you're going to get 2 pi. That's a horrible 2 pi. All right, so originally the period is from 0 to pi. Now it's going to be from 0 to 2 pi. So you can see everything is getting elongated, right? So if I was going to sketch my graph here, if I'm not shifting the graph at all, then I know I'm still going to start at 0. And instead of the period going from 0 to pi, I know it's just going to go to 2 pi. Now, you know that the x-intercept is halfway between my two intercepts. So I could just go ahead and sketch that here to be in pi. Now, the main thing we want to understand is what is this reflection about the y-axis going to do to the graph, right? And so what we can see is what we kind of looked in class is by these reflections of these graphs. That's basically just going to reflect the graph over, and you're going to have a shape of a graph that's going to look just like that, kind of more like the tangent function, at least the shape of that tangent function. The range is just going to be like that, is going to be negative infinity to infinity. And then the domain is obviously happening every pi n, right? But now the period got changed, right? The original period was every pi n. Now it's, 1/2 x equals pi n. Now, you could use the negative if you want to. It doesn't really matter. And actually, I'll use the negative and I won't use the negative, and I'll show you why those are the same. So if I use the negative, I'm going to multiply by, let's not talk about asymptotes, so let's just, let's talk about asymptotes. So if I multiply here by the reciprocal, I would get x is equal to a negative 2 pi n. If I don't use the negative, I get 1/2 x equals pi n, and x equals 2 pi n. No matter what numbers of n you get, you are always going to cross the vertical asymptotes of 0, 2 pi, 4 pi, 6 pi, 8 pi, negative 2 pi, negative 4 pi. So both of these solutions are correct. If you want to just use whatever's inside the function and just set it equal to your asymptote and solve, awesome. However, on a multiple choice test, I'd probably say this would probably be a more simplified answer that you would get. So you just want to make sure that you can convert from one form to the other. So, all right, guys, that is it for the free response and at least learning how to graph your reciprocal functions. Now what I'm going to do is just kind of take a quick little break before I get into my multiple choice questions, which I have kind of 4. So sometimes you just kind of need to do a break from teaching all day and then doing some more examples. But that's all right. That's what it's all fun about. So, Kungus, could you over college algebra logarithms a bit? Yes, I can. If you have some questions or if you want to tell me some specific topic that you want me to, cover for you, I will be more than happy to do that. But, just kind of, we don't cover logarithms in my pre-calculus curriculum anymore. So, that's not something that I have readily available that we've been using in my classes. All of the resources that I'm using for these live streams, those are for my pre-calculus curriculum, and we just unfortunately don't cover logarithms anymore. But if you do have some questions or you have a topic that you want me to kind of cover or a problem you want me to solve, just feel free to send it to me. I'll probably have an extra 10 minutes, or at least 10 more minutes left in the stream. So if you have that, I'll be happy to help you out. Yeah, Quincy says logarithms too. Well, let me know what you like. If you guys can just maybe kind of give a problem and let me know some kind of details that I can do with the logarithms, I'll be happy to see what I can do to help you guys out. So, Rockers and I2's my ball, dude. Yes, my man. I'm here. The eyebrow raise, the chosen one, infinite boxings, every report to be set. So I guess the SAT is happening again this weekend for those of you that are taking it. So, all right. So, sorry about that, guys. I'm not seeing any difference with my stream on YouTube. Seems like everything is going well, but it looks like I got kicked out. So, I don't know. I will come in there. If you guys keep on going through on the chat, then I will continue streaming, but I'm not sure if that's an error on my side or what happened. So let's go ahead and finish up the multiple choice questions. And then obviously if you guys have some questions or if you guys just want to make sure you add in the chat for me, let me know that the stream is still going on. I will stay around for a bit to answer some questions to help you guys out. All right, what is the range of the function? So again, I'm looking at this. First of all, I don't care about that. That's left and right. All I know is the range here is going to be the reciprocal of the cosine. And if this was a cosine graph, it'd be stretched from -3 to 3, and it'd be shifted up 1. So that graph would be from like negative, or it'd be from 4 to -2. And it would look something like that. So therefore, my secant graph would be obviously the reciprocal of that, right? So therefore, I need something with -2 and a 4, and I would go with C. The next one, if k cannot equal 0, what is the range of the function y equals k cosecant of x? So again, remember that's the amplitude of the sine function, y equals k sine of x. So again, to kind of think about it, whatever k is, that's basically telling you how high the sine and how low the sine graph is, as long as there's not a vertical translation like over here. So again, looking at the range here of this example, we can say that it's going to be -infinity to -k, so D. 3, the graph y equals cosecant of x has the same set of asymptotes as the graph y equals. So, to understand this question, I think it's very difficult for a lot of students to I need to memorize these. Again, let's think about what angles is cosecant going to be negative. So if we think about this as these coordinate points, 1, 0, 0, 1, -1, 0, and 0, negative. It's undefined because you're doing 1 over the y coordinate. And obviously it's not going to be cosine or secant because that's with the x coordinate, which is 1. And then, so therefore we look at tangent and cotangent. Well, tangent is y over x. Well, 0 over 1 or 0 over -1 is just 0. However, when we do cotangent, we get -1 over 0 and 1 over 0. So therefore the answer is going to be x. Chat is disconnected. Sorry about that, guys. Number 4, what is the transformations need to be applied to y equals cotangent of x to a plane y equals tangent of x? All right, looks like you guys are back in. Fatma, hi, how are you? So sorry about that, guys. I'm not sure. I'm seeing everything as stream health is good, so I apologize for those of you that are having trouble, but everything kind of looks good on my end. So. And then number 4, what transformations need to be applied for y equals cotangent to tangent? So, if we look at all of these, so from cotangent to tangent, so let's look at the tangent function. All right, the tangent function is, cotangent function. Cotangent function looks like that, right? Whereas the tangent function looks like this. So if I reflect the blue graph across the x-axis, that's not going to do anything. If I reflect the blue graph across the y-axis, that's not going to do anything either because, again, this intercept is at pi halves. If I reflect it about the y-axis, I'm still at an intercept of pi halves. And then if I just shift it pi halves to the left, I still don't have the same graph. So the only one that works is going to be D. So there you go, ladies and gentlemen. That is our answers for graphing our graphing our trigonometric functions. Looking into main idea here is really understanding what the asymptotes are as well as the range. And, really being able to use the reciprocal functions, mainly the sine and cosine, to help us understand, the range and the domain of these functions. So just kind of work through everything, looking at those different operations and transformations that can be applied to the functions. And so hopefully that was able to help you guys out. But if that is it, then I will be able to answer any questions you guys have. So I say, Ashlyn Will says, can you do literal equations? I can do literal equations. If you can maybe like type in a quick literal equation or explain to me one that you would like me to do or explain, I'll be more than happy to do that. I'm doing included side, angle, angle, side, etc. question. I don't have any of those like available like right up to me. Like those are not equations that I can just like pop out on the top of my head right now. We are going to be covering that not for another month. So I mean, if you have like something with the side lengths, like what side lengths are what of the triangle, then I can help you through a problem like that. But you'd have to like kind of tell me a little bit more. And Ashlyn, just tell me what you want me to do for literal equations, and I'll be happy to do a problem. But anything that you can show, if it's just formulas, or if you want me to do a literal equation in terms of like, y equals mx plus b, then I'll be more than happy to help you out with that. And then obviously we have some suggestions for the logarithms. If you guys can let me know what types of problems, and here where it kind of comes into, I loved in the live streams, but I do kind of have a hard thing. All right, Ashlyn, what are you trying to solve for? P is equal to R minus, is it C over N? Or were you trying to write R minus C over N? I don't know why it keeps on kicking me out. Sorry about that, guys. Hopefully, it looks like it's back up. So I'll go ahead and solve for R. And but anyways, if you guys just want to make sure that you are keeping on track. Now, actually, you didn't tell me which one it is. So guess what? I'm going to solve for R for both of them. So anyways, guys, if you want to solve for R, literal equations, all you're trying to do is undo what is happening to the variable. So one thing I like to do is, you can kind of circle the R. And one thing, the reason why I sometimes like to circle R is I'm like, all right, the R is not going to change. All I'm going to do is undo everything that is happening to the R. So in this first example, if I'm take from the R, I'm subtracting a C over N, well, then I just want to undo subtracting a C over N. So I'm going to add a C over N to the other side. And therefore, I would have P plus C over N equals R. And that's basically as simple as that one can be. Now over here, I am subtracting a C, but I'm also dividing by an N. And so this can actually be rewritten in a couple different ways. We could actually distribute the N to both of them. So it'd be P is equal to R over N minus C over N, which I think just kind of gets confusing here as you look at this. And, there's a couple different ways you could do this. You could add, again, the C over N to the other side and then multiply by N. But there's a really kind of tricky way. If I want to get rid of N off the denominator, like basically all I simply need to do here is just multiply by N on both sides. When I multiply an N on both sides, and again, you can apply this operation. This is a property of equality. As long as you apply the same operation to both sides, then you're fine. Like if I have 3x is equal to 9, and I multiply both sides by 2, then I'd have 6x is equal to 18. The answer is still 3. So when I multiply by n, though, here the n's are now going to divide out, and I have np is equal to r minus c. Well, now my r, which is pinned, is being subtracted by c, so I'm just going to undo subtraction by adding on both sides. So I'd have np plus c is equal to r, and then I can just rewrite the r in front. R is equal to np plus c. So hopefully that helped you out, Ashlyn. The Tech World says, good teaching. Thank you very much, man. I appreciate it. So if you guys have any other questions, anything else on literal equations, logarithms, anything else, I am going to kind of put in, I think, my community tab. I'm going to let you guys know, for those of you who kind of follow along the community tab or are on my Facebook and are part of the free math videos page. I'm going to put out some notifications, let you guys know that I'm going to go, I think, live this weekend. And I'm not going to bring any material with me. I mean, obviously I will have some material for me because, if nobody shows up and wants to help with their work, then I'm not going to have anything to do. So I'm going to have to do something. But my goal is not to have anything defined. Like here, obviously, I spent 30 minutes going over homework answers. So I'm not going to do that. I'm just going to say, hey, if you guys have some problems that that are going to be on these tests that you have coming up or final exams, send them to me early so therefore I can prepare just to make sure I have enough content prepared. But obviously, during the live stream, if those are some questions that you join in, you want to add into, then awesome. I'll answer those questions as well. So, do you stream homework answers every day? Well, we work in a block schedule, Kim. So I don't see my students every day. I see them every other day. But yeah, I try to get my homework answers available to them, after I've taught the lesson for both A day and B day, then I will stream the answers. So, my kind of structure is by the time they take the test, they have all the answers to their homework. They have all the answers to their quizzes. And again, I don't do that because they have to get good grades, because obviously you talk to any of my students, still the grades is, something that students still struggle with. But I do that so students can, have everything they need to be prepared for that test, in addition to staying after school and being able to help them individually if they need. But, I think the online component is something that's very helpful for them. Vector Marcus says, Brian, is there a way to pay you from some personal help I need? Yes. So if you haven't already noticed, obviously I really kind of, put in a lot of effort to do this for my students, because, this is obviously, they're in my class. And in the same respect that, obviously the channel, I kind of treat you guys as like my students as well. And I do these, live streams as a way to not only to connect with you guys, but if you guys are taking, courses where you're covering these topics, I want to be able to help you out. Or for instance, if you're not taking a course like me and you're just doing literal equations, I'm happy to answer questions. But as far as doing online, and doing any kind of like private help, I just don't simply have the time. Like after right now, I got to leave here in the next 2 minutes. I got to go and get my girls, and then it's dinner time, and then it's preparing for my classes for next day. So I've set up some time for my videos after school, but really besides that, I don't have any extra time, so unfortunately I apologize, but I don't have the time to really fit in. Once I get home, it's just more work besides family time and dinner. So I apologize, but the great thing is there is a lot of great tutors though that you can get that personalized experience. I love obviously making YouTube tutorials, but I've also done private tutoring years ago, and I do know that experience, or also having a tutor myself, how much that can help. But I would just check it and go through it. There's definitely some people that are really good explainers that will be able to help you out. I'm in liberal arts and I'm struggling. Ashlyn, just keep on working at it. It's, Grace says derivative of e to the x. Yes, e to the x. Actually, I just say keep on working at it. I know a lot, it's some of the stuff is hard to remember. Some of the stuff like literal equations is like, why are we doing this? And it's hard to like make those connections. And obviously I can't get into much of your like experience or past math experiences. But I would just say, keep on doing what you're doing. One of the things when I was struggling with math, I was at the tutor lab all the time. I was always asking the questions, and I was just determined to get, that grade and pass. And I think if you can just turn on that determination, regardless of your math experiences in the past, the teachers you've had in the past, anything else that has maybe given math a bad taste for you, just keep on working at it, keep on seeking out that help and putting in the effort that you need to do to be successful. And I'm telling you, you put in that effort and you get the help that you need, you can definitely do this. This is not an obstacle that is out of your reach. Just keep working at it. Kim says, I'm in pre-calc and it's kicking my butt. Well, Kim, totally get it. Hopefully you guys are on like kind of the same schedule as my class. We're going to get into analytic identities, analytic trigonometry identities in here just about an hour after winter break. So, but yeah, everything I have as far as my quizzes, you'll see on my live streams, and my homework answers on my live streams. Everything like that is online here on YouTube. And then obviously I have these resources available in my membership side, like my channel membership or on Patreon, if that's something that interests you. But, everything as far as the videos go is available here as well. Sania, what's up? Good to have you in here. Blurring out astronomy and struggling. I'm always interested in astronomy. It was always something that I never really got to like continue on though. But it was always something that I was interested in. My dad teaches math to me just the same, and that is a compliment. Oh, well, I'm very happy to help. My mom was a math teacher, for those of you that were not aware, so I kind of liked it, but kind of didn't like it. It was nice to have somebody that I could ask questions to, which is an advantage, but it was also one of those, like, you don't want to have any there. I want to have trouble with trig equations with solutions. Vector market, if you go to, you're looking for trig equations and solutions, I have a ton of examples on trig equations and solutions. We're not there yet. We're not going to get there till after winter break. But I mean, if you just go to my channel, go to my playlist, and just look at the pre-calculus, or just type in solve trig equations, I probably have equations of like over 80 videos. And I'm not sure that every video is going to be the best explanation that's going to help you out, but I guarantee I have a ton of variety of examples of problems that can help you out, and hopefully to further kind of explain those concepts. So yeah, so trig equations, multiple solutions, I have a ton of those examples. Just look at my playlist on my channel. Go to my channel, playlist, type it in. Obviously, if I wasn't going live right now, I would just go ahead and get the link, for you, but you can, I have a ton of them, multiple examples, whole slew of those examples. So I'm going to check that out, but I do need to go ahead and head out for the day. Time to go and get the kiddos, but I do appreciate you guys joining in, and I apologize for the disruptions on the live stream, but we are done for this week. Next week, we are taking a quiz on trigonometry. So therefore, I will plan on going live, and look out on your notifications on YouTube as well as on Facebook. I will possibly be looking to do another review session for any math that you're taking this upcoming weekend. So look out for that. I just don't want to confirm anything right now, but look out for Saturday, Sunday. I'll try to give you guys as much advance notice as possible. So otherwise, guys, I appreciate you joining in, and hopefully I'll be able to help you out. Cheers.